experience and what is your background and why you are interested in learning big data Hadoop basically, right? So let us start from. I'm sorry, Kathiresen. I'm
Yeah, I'm
sorry.
Kyathi. Yeah.
Oh yeah, okay, Kathiresen. I would just like to know something about you, right, and your interest.
Yeah, basically, I'm a Java and Oracle developer with a bit of ETL and data warehouse background. I just want to learn about big data, Hadoop, and all the upcoming technologies. I just want to get a feel of it and see whether I can, um, whether that suits my skill set, whether I can upgrade all that.
Okay.
And basically look for opportunities in that area. Yeah, that's it about me.
Okay, that's very good. Okay, as you mentioned, I see you have mentioned about Java as well, right?
Yeah. So I have around 14 years of Java and Oracle experience. Yeah.
Oh, perfect then. Yeah. Okay, fine. Okay, so I would like to know something about you, Kiran. Hello, Kiran, are you there? Are you able to hear me? Can you please speak out? Okay, fine, no problem. So probably Meera. Meera,
Yeah,
can oh Kiran, you okay? Yeah, please go on, Kiran. Okay, Kiran has some
yeah. Can you hear
connectivity.
me?
Yes, I'm able to hear you, Kiran. Okay, that's fine. So Meera, probably Meera Srini. Oh, I'm sorry. Srini, can you please give your intro?
Hi, I'm Mira, and I work as a data architect here. I was, since I've worked with almost all types of data, and I'm just now getting familiarized with big data, so I wanted to see what your training can offer me and what I can learn. So looking forward to this.
Okay, good. Okay, fine. Got it. Okay. So Venkatesh.
Hi, this is Venkatesh. Basically, I'm a tester. Um, so I would like to learn this big data. What this big data can teach us.
Okay. Okay, fine. I got it. Okay. So I'm just muting you all, right? Please don't mind. But usually in our classes you are not muted, but here I'm just muting you all. Okay. If you have any questions, obviously you can raise them in chat window, right? It's fine. So ultimately, yes. So it's all about data. Yes. So before going into what is big data and all, so as we all know, like data is there in various forms basically, and wherever we go, we see a lot of data, right? So we see data in the form of databases, all these flat files, XML, Excel, Word, PDF, image, you know, everything is data basically, depending on the company to company. So for them, that is data, right? And okay, now coming to big data, so how much data we are talking about, right? So were talking about megabytes and gigabytes, and then slowly we moved into terabytes, and now we are talking in terms of petabytes. Of course, not every company is talking in terms of petabytes, but most of them have started having hundreds of terabytes for sure. Okay, so a lot of companies have hundreds of terabytes of data. Of course, these are just big numbers, but if you see here, right, so you see a couple of numbers here, but out of them, basically one number, so this particular number is about the amount of data that company already has, and this is about the data which is flowing in, incremental data which is flowing in monthly, daily, or okay, in some periodic time, basically, right? And when these two are huge, probably when your volume of data is huge or your velocity of data is huge, or you are working with variety of data, of course this variety I cannot say, or basically you need to have this volume and velocity, and of course variety basically, so these two are mostly about the amount of data that is the storage problem, and this is about the computation problem, because processing this variety of data is time consuming, and ultimately we also face computation problem, right? So basically there are just two problems, storage and computation, right? So big data is trying to solve both these problems basically, okay? And any technology which tries to solve this particular problem, it comes under big data stack, right? So big data is a very broad term which actually describes about any technology, as I mentioned, which is trying to do these two, solve the storage problem and computation problem. And Hadoop is one such technology which is quite famous and which is obviously leading the stack. And apart from Hadoop, the next thing which you hear about is Cassandra. The next thing which we hear is MongoDB. Okay, and apart from these two, you might be using a lot of other technologies, but you will only see it once in 1,000 requirements, or 1 in 100. That's it. Fine. So of course, okay, this is about the data. Basically, statistics say that, okay, don't worry about this graph, but ultimately statistics say that every 1.2 years, data is doubling across the companies, across the world, right? So most of the companies at least. And this is just another slide which says about velocity, right? So from 2009 to 2020, they are expecting a huge surge of data. Right now we are somewhere here. So we have not yet seen that huge surge, right? So this is another analysis which is shared by EMC Square, right, in their paper called Digital Universe Study. And then this is just about variety, wherein you see that 90% of the data is basically unstructured data, and the companies see a lot of value in that particular unstructured data, and they want to process that, right? And they are processing it, but it is time consuming, and they are just discarding a lot of data because they cannot process it in the required time. Okay, and especially in the ETL jobs might run for 48 hours or more than that sometimes. Okay, and then that is where this particular this computation problem and also storage problem, right? That is where you see this. So these are just some couple of comments which are shared by this McKinsey, Gartner, and Forrest researcher, and they say a lot about big data, and ultimately they talk about Hadoop in specific. Right, and this is just to basically why these particular companies are collecting this data, right? Well, what are they interested in basically, right? So when we look at the business side of it, of course there are n number of use cases, but I would just want to focus or highlight if people doesn't know about these use cases, then they would just get to know about this, right? So that is the only intention. So if you take a very small example of Google search, right? So they usually share their analysis every 6 months or a year or quarterly, basically, saying that so and so product is most popular product, and so person is most popular person, right? So how do they know about that, right? So they are basically analyzing whatever we search. So we are just not consuming the content, we are also generating some data, right? So from that particular data, they want to do some analysis. So how many people might be doing Google search in a day? A lot of people actually, right? So if you imagine, so probably at least I do 30 days, so Google search 30 times a day on a working day at least, right? And probably at least if I say only 1 million, only 1 million or 2 million people are using Google search, right? And you can just say that at least 30 to 60 millions of records are actually generated, right, in a day, right? And if you multiply it by 30 in a month, and if you just look at if you just multiply it for a quarterly or half yearly or yearly, right? So then you would see that it's quite a big number. So that is the need of Google, of course. That is the reason why Google were the first, one of the first, basically they are pioneers of big data. They are the first ones to use the big data, obviously, in indirectly or indirectly, basically, right? So retail, okay, coming to this particular retail use cases, right? So so these guys basically want to generate some recommendations, right? So wherever you see, whenever you log into these pages, you see somewhere, right or top, bottom, somewhere you would see some recommendations. So how they are able to recommend that accurately, that, and because they are tracking each and every activity which you do, and they are able to analyze the data in time, right, within some hours, and then they are able to provide you some recommendations. So that is their motto. Okay, and this particular, so now where this particular data is coming, right? So okay, this is a use case, but why do they need big data? Basically, if you see, they are tracking each and every activity of a particular user, and they have millions of customer base, and every user, if a user do lot of clicks, then it will be pretty huge data actually. It will easily run into, like 5 terabyte, 1 to 5 terabyte. Okay, so across the world, right? So in that particular case, it obviously becomes big data problem. Of course, these are just some small use cases which I am discussing just to bring your focus or bring your attention, and make you understand something about the use cases, why this big data surge is actually coming in. And also, right now, lot of digitization is going on across the world, right? So there are a lot of countries which are not using, internet to a lot of extent actually. So if they also start using it, then if a lot of digitization is happening in those countries as well, then it will again, the huge surge will come in actually, right? So we have use cases across these particular domains, right? So any domain, you just name a domain, we have a use case. We have at least one use case in a particular domain, right? So why they are doing it? Why they are using it basically, right? So ultimately they want to do some analysis. Basically, of course, they want to generate some reports and see what is going on basically, and why it is analyzed, why it is happening, and they also want to see what is going on right now, and they also want to predict. So with the help of machine learning algorithms, we are able to even predict the future behavior of the customer or future behavior of respective entity. Now, why we are talking about big data and analytics? So this prediction is basically, of course, predictive analytics, right? So why we are talking about big data and analytics? So can't we do analytics without big data? Yes. So analytics was there from 20 or 30 years back as well actually. Okay, and 20 to 30 years back actually, right? So it's not something new. But why we are talking about big data and analytics? So basically, analytics works on a very simple fundamental that the more data you have, the better results these analytics can actually provide. Okay, and previously they used to do a method called sampling, wherein they would just draw some data and then they analyze only that particular limited amount of data, but not the complete data set, right? So their accuracy was limited. Now that they are able to analyze this complete big data set, they can actually give very accurate information about a customer, right? And ultimately the companies can do better business and they can earn a lot of money, right? So that is the ultimate motto. Okay, now coming to Hadoop basically, right? So Hadoop can actually process anything. It can do text mining, it can process audio, it can process images, video, anything actually, but mostly 90% of the unstructured data is text-based unstructured data. Okay, very few companies work with audio, video, and images. Okay, and they would have their own specialized APIs to work with them. Okay, they will have their own patented algorithm sometimes. Okay, so 90% of the companies work with text-based unstructured data. Yes. Don't deceive yourself. If someone says that okay, audio video files can also be processed, can't we process audio video files right now? We can process them. You write a very simple Java program, you can process anything in this world actually. Of course, provided you have an API, or provided you have a knowledge that you write your own API, right? So same API can be applied in Hadoop or big data, basically, right? Any of the big data technology or Hadoop, basically, any of the Java based or .NET based on anything. Basically, you need to have the logic to process that. Then you can convert that logic into this particular big data solution. Now coming to Hadoop, right? So Hadoop is basically an open source software. So it's free of cost. You don't have to pay a single penny to anyone, and it's reliable. How it is reliable, right? So basically in Hadoop, basically what happens is your in general any of the system. When I say system, any of the data storage system, right? So that data storage system will have two other replicas. So ultimately you are making three different replicas actually, right? So that is okay. The same thing will happen in Hadoop as well, but Hadoop basically works on a fundamental that it uses commodity hardware. Commodity hardware is cheap hardware which is easily procurable and which doesn't depend on a particular configuration, right? So it is easy to use ultimately, and it will bring down your cost. So this commodity hardware, on this commodity hardware you are actually doing the replication. So Hadoop is also making the replication, right? So it internally uses this default replication of 3, okay, and it is making sure that the data is reliable. Yes, in general also, so that a lot of these systems are actually reliable. Yes, so this reliability is not specific to Hadoop, but being reliable and also being scalable is the specialty here, and also it works on this concept called commodity hardware. That is, you just give a 1 GB RAM machine, even then Hadoop can actually work. Okay, you give 100 GB RAM machine, Hadoop can work. So there is no such specific requirement for Hadoop. Of course, there are some standards which are maintained. It's a different case which we will discuss. So coming to scalability, we have two concepts here. So one is vertical scalability and the one is horizontal scalability. Vertical scalability is you have a system, right, and then you are trying to replace this particular machine with a bigger machine because you need more RAM and more space. Okay. So ultimately you would have one machine or limited number of machines basically, right? That is called vertical scalability. And in horizontal scalability, so you don't have such limitation. You can just keep on growing your cluster size. That is, you can keep on adding these new machines and just add them in network. And so all these are added in network basically, and right now basically Yahoo has much bigger cluster than the number which I am saying. At least 50,000 node cluster. At least 50,000 machines are actually connected together, okay, to run this Hadoop software basically. Okay, so that is much space actually. Okay, so no other software can actually scale to that extent, or no other technology can actually scale to that extent at this point of time. That is for sure. And coming to distributed computing, so basically, okay, before going into that, I would just want to explain you about distributed storage. Right, so let's assume you have 100 GB of data and you have 100 machines. So basically in Hadoop, all these 100 machines are actually connected over network. So don't worry about the network part of it, right, which we will anyhow discuss in our class. In Hadoop, basically you will have approximately 1 GB placed in each of the machine. So this is machine 1, and this is machine 100. So basically your data is divided across these 100 machines, 1 GB approximately, right? So this is called distributed storage. Now coming to distributed computation, so if you want to process this 100 GB of data, then a job is actually divided into tasks, and these tasks will be assigned on each of this machine, and this 100 GB will be processed on respective machines. So basically all these 100 machines are working together to process this 100 GB of data, right? So that is called distributed computation. Now in Hadoop basically we have two major components. One is called HDFS and the other one is called MapReduce. So storage part is taken care by HDFS. This 1 GB, this 100 GB is actually is divided into 1 GB in all of these machines, right? So that part is taken care by HDFS. How it is taken care, we will discuss in our class. So don't worry about it right now. Okay. So the intention of this particular class is to give you a very high level overview of what happens basically, and then we will slowly enter into each of the details. There are a lot of details which I am abstracting right now, right? Okay, and then so this part, which is computation, I will just say compute, is taken care by MapReduce by Yarn. Okay, of course, Yarn is again nothing but MRV2. If you know these terms, if you don't know about these terms, don't worry about them. Okay, MapReduce is called MRV1 and Yarn is called MRV2. Okay. So Hadoop basically is a framework which combines this HDFS and MapReduce together and ultimately solves storage and computation problem and also scalability issues, right? Of course, Hadoop is reliable, right? It is scalable, and it is economical because it runs on this concept called commodity hardware, right? So it is very cheaper when it is compared to a lot of production grade machines, basically, right? So Oracle or any of these machines ultimately, right? So they usually use 400 GB RAM machines, but in Hadoop we use large number of small machines. So of course you might have this thought like, okay, this ultimately it is going to be the same cost, right? No, it is not going to be the same cost. So let's assume for a 400 GB RAM machine you are going to end up paying $50,000. Let's assume that, okay? But you can actually get smaller within that $50,000. You can get a lot of smaller machines which can actually give you close to 1000 GB of RAM. Together they can actually give you 1000 GB of RAM. Okay, so that is the difference which is there basically. Okay, so of course you can actually understand that part if you have really worked with production grade machines or you know about the costing issues. Okay, and of course there is some licensing cost which is involved, and of course even Hadoop is free of cost. Even when I say free of cost, there are some commercial editions within Hadoop, right? But even then they are cheaper actually, which we will talk. And it is also flexible. Okay, so when we talk about flexibility, right? So here in Hadoop basically you can just first store the data and then you create your schema. But usually in normal systems like whatever we have been working till now, right? First you need to have a schema. That is, you create a table first and then you dump the data. But in Hadoop it is reverse. You first dump the data. Don't worry about what is there in the data if you really don't want to right away. Just dump the data and then think of processing that data. Okay, and you can create dynamic schemas on the same data. That is, you can have more than one schema on the same data. Okay, that is more than one table on the same data set. Okay, I'm not talking about replication again. Okay, this data set is again not made, another data set copy of it. No, okay, it's not copied. The same data set, you will have two different schemas. Okay, that is possible actually. Of course, we are going to see that practically again. So everyone is using Hadoop right now, yes? Okay, fine. I just named this particular thing as Hadoop Jungle because there are a lot of components which are built on top of Hadoop. Of course, Hadoop itself is has come from this an animal toy actually, right? So Mr. Dow Cutting, who is who has invented or who has created this particular Hadoop software, he has actually gifted his son a toy, a elephant toy, and for some reason that kiddo just called it Hadoop, and that name has been given to this software, right? So, and that is why you see wherever you go, wherever you see this Hadoop, you always see that that elephant symbol there, right? So okay, that is how it started, and after that, a lot of people have added other components which work on this particular Hadoop. That is on HDFS or MapReduce, right? So it's something like Hive, pig basically. It's not an abbreviation or small form basically, right? So it is pig, PIG, pig. That's it. There is nothing else. And Impala, and there is something called zookeeper, someone who takes care of zoo. All these components basically, right? So we have two core components called HDFS and MapReduce, and we have ecosystem components which I am calling here as animals. So all these are ecosystem components. So we are going to discuss all these ecosystem components. We are going to work on all these ecosystem components, and apart from that, we are also going to work on some other ecosystem components as well. And coming to Hadoop distribution, so we have, as I mentioned, right? So there are licensed Hadoop versions as well. Basically, Apache is the one which is maintaining this particular Hadoop, and it is licensed by Apache, and Apache is an organization which maintains all these open source technologies. So Apache Hadoop is obviously free of cost. You don't have to pay a single penny to them. Then these guys took this particular Apache Hadoop, and then they are just provided some UI, some user-friendly UI as per their customers' needs, and then they are also providing support. So you pay money, they will provide support. So if you use Apache Hadoop, and if you need help, either you have to hire a specialized Hadoop guy, or you just have to rely on forums. But if you use any of these, then these guys will help you to implement Hadoop, and also they will give you their UI, and they will also provide, obviously the support is what they are selling basically. Okay. So Cloudera, Hardenworks and Mapper are particularly famous and quite used. Quite a lot of them use them basically. Use this distribution. So in our class we are going to work on Apache Hadoop. First start with Apache Hadoop and understand the internals of it, and then start working with Cloudera, Hardenworks and Mapper. And then Hadoop on cloud, yes. So cloud has a lot of significance when it comes to Hadoop, because here in cloud we are interested about infrastructure as service. Okay, we want to take infrastructure on lease from cloud. Okay, and most of these companies use Amazon EC2 to create these machines and then use them and discard them whenever they are not interested. Of course, that is the flexibility which cloud is providing. So in our class we are going to work with Amazon EC2. So I'm going to show you about Amazon EC2 and how these real-time projects look like, basically how real-time environment look like, and then we are going to create a Hadoop cluster on it, and then you are going to see how we can connect it to it remotely and all. Okay. And yes, we also have certifications for Hadoop, Cloudera, Ardenverse, and even Mapper is also providing certifications right now. For Cloudera and Mapper basically charge $295 and the Ardenverse charge $150 for certification. Almost all of them has 70% as pass criteria basically. Okay. And in our class, I'm going to highlight everything which is going to be part of certification, and obviously I'm going to share Cloudera certification dumps as well, actually. Okay, because that is the one which is quite famous, and as I think I did not mention this, right? So Cloudera has this 50% of market share in commercial distribution. So Cloudera insists their clients to have their resources, have Cloudera certification. So ultimately, they are also trying to make business from that point of view, right? Again, so this whatever companies which relay or which are actually trying to implement Cloudera Hadoop, right? So they always try to hire people with Cloudera certification. Of course, this is just a doctrine. Again, I took it way back again, actually mid 2011. So I just kept it like that, and so of course, right now it is not exactly going on like this. So it is going on like this probably. So that is what I see. And then this is just another slide which talks about the amount of money which is going to be pumped in. So we are actually in the middle right now. So 2018 and okay, basically there is a lot of money to be pumped in. Okay. Right. So okay, fine. So in the end, again, we are going to discuss. We are going to work on POCs. Right. I'm going to discuss how the POCs, how these proof of concepts are done, and we are going to discuss about the architecture of the projects in general, how these projects are executed, right? Which component is going to help in doing what, and how these various components become a project, right? So that is that will come in the end again, right? So after you understand each and every component, and after we practically do work on each and every component, then we are going to see the project perspective. Right? Only then you can understand. If someone says that you can understand it right away, please don't believe. Of course, overview can be understood, but if you have technical questions, then you cannot. Right? And again, so I'm going to share resumes. Yes, so that is common. And I'm going to share this Cloudera Cloudera practice questions which I have mentioned. Right? So Cloudera basically charges $125 for that practice question. Right? And then. And what else? Yeah, okay, okay, fine. So all these basically, right? Okay, and then all the resources will be shared on something called Piazza, right? So basically, Piazza is mentor-mentee site. So wherein all the documentation shared in everything which is shared in this is actually available for lifetime. So all that you have to do is just log into it and then start using it. That's it. Okay, this is just 37th batch which this is my 37th batch. So okay, we have 5 guys enrolled in it, right? So even if you take average of it, then it's close to 200 basically, right? So I've already trained at least 200 people. Initially the batch strength was even bigger actually, right? So 10 to 15 actually. So it's much bigger number, right? So this is going to be 38th batch, yes. So this is the current batch which I'm talking about is basically running in the morning, right? So we are going to have the next batch basically on weekends, right? So let me just share some details of this. I think I'm not supposed to open that. Okay, fine. Yeah, so I was just talking about these timings, right? So basically it is going to be 7:30 p.m. to 10:30 p.m. and it is going to be there on both Saturday and Sunday. And when I say this PM, that is going to be IST. Yes, that is very important. then we are going to have it, these classes approximately for 40 hours, and that will be close to 5 to 6 weekends. Okay, and then $350 is the fee. And yes, if you, and basically you will need to have understand Linux commands. Basically, you need to understand some Linux commands, and that anyhow, don't worry about the Linux part of it. We will anyhow discuss that, and we will work on Linux actually. Okay. So don't worry. When I say Linux, I am not expecting you to just set up all the complete system, right? Okay. So don't worry about that too much. And having Java knowledge will help you basically. Java guys will have, of course, non-Java guys will also have this Hive and Pig, right? So it's not mandatory, but it will help you definitely. Of course, we have a number of other components like Flume and all, wherein we may not have to deal with Java a lot. Okay, but still, if you have to do any customizations, then yes, Java knowledge will help ultimately. Right, so we will. So I will take your questions now. So if you have any questions, you can just shoot. So can you please, if you don't mind, can you please type in your question in chat window? So that will just be easier actually. Of course, in our class, okay, let me just, I think only few or 4 are there. Let me just, yeah, I think probably you can just type in your question in chat window for now. Yeah, for today, that will be better. Are you there? Okay, I think. Oh, okay, that's very good. Yes, when is the session starting? I'm not a big Yes, yes. So you can still proceed with the class. Yes. So yes. So guys, everything we'll be doing in practical. So there is nothing like, okay. So we will have only 30% of theory. 70% will be practical. Okay. So in the end, you are going to have your VM. All these VMs created, Cloudera VM, Hardenberg's VM, and Mapper VM, all these VMs will be created on your laptop. Okay, so 70% of this training is going to be practical only. Okay, who will be taking the classes? Okay, that's a good question. So you don't want me to take the classes? Ethresan, you're not interested in me? I'm sorry if that is the case, then I'm going to take the classes, right? Yes. Yes, as you're coming to me, right? So I think I did not give my introduction, right? So I'm Satya, right? And I have 12 years of experience and in IT, and I have 4 years of big data Hadoop experience, right? And I'm working as a Cloudera an architect, basically. Cloudera architect specifically, okay? And yes, I'm Cloudera certified Hadoop developer as well as administrator. Okay, and as I mentioned, this is going to be my 38th batch, and I have already trained at least 200 people till now. It's more than 200. It's close to more than 250 actually, but I'm just saying you more than 200. Yes, Catherine, it is going to be me only. Yes. So you're not happy with me? Of course, I'm not. I'm just kidding. Of course, you can say that. Okay. Oh yes, yes, Catherine. If you really want to talk, give me 1 second. Let me just unmute you. Basically, in class again, right? So as I mentioned, you will never be muted actually. Okay. I'm sorry if I'm pronouncing your name wrongly. Please correct me if I'm.
Yeah, Satya, it's good actually. So just want to check the format of the session and how will we. So what are the prerequisites for every class, and so if we were well informed, we can also prepare prior to the class and.
Yes,
So
so
basically,
basically,
yeah.
I would actually request you to, if at all, basically, I would just request you to brush up your Java skills, whatever Java you know, or whatever programming knowledge you know, or whatever programming skills you know. Just brush up your programming skills, and specifically Java, right? And if you know Linux, then if you know Linux, then just try to brush up your knowledge, or don't worry about it, because anyhow I am going to teach all those prerequisites. So this anything all these prerequisites I'll be covering in class itself, so you don't have to worry about them actually.
Yeah, but when you say Java, it's any particular area of
Yes.
IO or any specific
Okay,
area?
that's a good question. So don't worry about any of these IO and all, right? Specifically about these things. So I would just tell you, just worry about Wood's concepts. That is, just worry about inheritance.
Okay.
Just worry about abstract class and interface. Right? So just have basic understanding about them.
Okay.
And just try to have understanding about what is overriding. Okay. And have understanding about generic classes. That's it.
Okay.
So don't worry about any of the other concepts.
Okay. What about data side, database side, anything particular?
So if you know SQL, that is good, because HiveQL, that is HQL basically, is very close to SQL. So if you know SQL, well and good. If not, you will learn it now. Of course, it's not going to be SQL, but it's going to be HiveQL.
Okay. All right.
And rest all, it will be new to you, but it will be very simple, just like SQL.
Okay. So is 40 hours is sufficient to learn the entire stuff and all the related technologies, or?
Oh yes.
What do you feel?
Yes, 40 hours is good actually, but this 40 hours only includes me talking for 40 hours.
Okay.
Right?
Okay.
Me talking and me doing practicals and me helping, basically me implementing it, right?
Okay.
And then you will definitely have to spend another 100 hours. Of course, I'm just telling it, but whatever time you can actually spend, right?
Okay.
So this is going to be. Yeah.
So how much time you think probably we may need to spend on a weekly basis? Say for a week.
Yes.
So
Yes.
on a daily basis, we'll spend 3 hours with you, and then on a given week, how much extra time you think we may need to put in order to understand more effectively and in detail?
Yes. Okay. So I would suggest you to spend another 1.5 hour to 2 hours personally.
Okay. Okay.
Each day.
Okay. Every day. Okay.
Every day.
Oh.
Again, that also depends on your level of understanding as well to some extent. Right? So.
Do you have any kind of homework kind of stuff? Anything?
Yes. Yes.
Yeah.
So basically, the material which I am going to share is prepared in such a way that we have a lot of commands in that, right? So I mean, like examples in that, right? So so conceptually, everything I'll be discussing and running an example in class, and one example at least you will have for you to run at home. So anyhow, whatever examples which I run, even you have to run, because you're not going to do practicals parallelly with me, right?
Okay.
Okay, so you will be getting this recording, whatever I have spoken.
Okay.
So you will be getting that recording immediately on the same day.
All right. Okay, and last question: do you have any kind of project or any use case kind of scenario so that we can just try out and see, just to relate to a real-time
Yes. So
experience?
yes. So I'll be actually sharing lot of use cases and lot of scenarios. Okay, while we are actually working with each of the concept. With each of the concept, we'll be having such scenarios basically.
Okay. All right.
Okay, good. So anyone has any questions? I'm glad that Katreshan has already asked a lot of valid questions. Actually, that would have definitely helped others. Yes. So one question I did not answer is when we are going to start the session. That was the first question which was actually asked to me. Right. So we are going to start these sessions on this 6th of June, basically. Okay. So we are going to start this session 6th of June. And as I mentioned, you will be getting all the recordings as well. Right? So though you miss any of the class, you are not missing anything actually, because you will always have the recording. Okay guys, I see that you don't have any questions. So good, then I have one last question for you all. Yes, so just ask this question to yourself, and then take an informed decision, and then just come back. So let's all meet in our class and continue our discussion. Thank you guys. Oops, I think I just got a question. I was about to. Oh, okay. Someone said thank you. Okay, thank you guys. Thank you very much. Thank you very much for attending this demo, and hope to see you in class. Take care.